Here's the slope and direct variation test review video. I'm going to try to go pretty quickly, so you might have to pause every now and then to stay with me. So the first one, we're going to find the slope of a line. So to do that, we have to do rise over run. But we also need to check our graph and make sure that it's counting by ones before we do it. So this graph is counting by ones, so I know every time I rise it's just 1 unit. If it wasn't counting by ones, when I rise I'd have to rise however many it's counting by. So like if it was counting by 2s, each one of these little hash marks would be rising 2, 4, 6, and so on. But in this case, 1, 2, 3, 4, 5, so I know it's counting by 5. So I know I have a point here, and then anywhere that it crosses at the corner is also a point. So I can pick any of these points to do my slope. I'm just going to pick these two here in the middle. So I would rise 2 and run 1. Since I'm running to the left, I know it's going to be negative. Also, this line makes an N. If I can create an N, then I know it's going to be a negative slope. And 2 divided by 1 is 2, so my slope is negative 2. Next one, we're going to use this table for the next few questions. So I have time and how much is charged, and it's dog walking. How much does Dan charge per hour for walking dogs? So I know it's $5 for 1 hour, $10 for 2 hours, so on and so on. So I can divide 5 divided by 1, which is 5. So it's $5 per hour. This one, the table was pretty helpful. What's the equation shown? Well, the rate of change is 5, because 5 divided by 1 is 5, 10 divided by 2 is 5, 15 divided by 3 is 5, so my equation would be y equals 5x. And then the missing value in the table is going to be 20, so $20. Because I did 4 times 5 and I got 20. Does this data show direct variation? So remember, for it to be direct variation, we need to do, see if the k is constant, so y divided by x. So in this case, this is my x, this is my y, so I would do 1 divided by 50 and I get 1 over 50. 2 divided by 10, it's not 10, it's 100. 2 divided by 100, could that be reduced to be 1 over 50? Absolutely. Then this one would be 10 over 500, which would also reduce to be 1 over 50. This one would be 20 over 1,000, which could reduce to 1 over 50. So yes, it's direct variation because the k is constant. The k is the same all the way. So my equation would be y equals 1 over 50x. Which equation shows direct variation? Remember, it has to be in y equals kx form. There's nothing after there. Well, so this one's a little confusing because there's none of them that have a number in front of x. But I can already tell that these have numbers added on the end, so I know they're not right. So it has to be a, but let's talk about this a little bit. This actually means 1/2 x, because 1/2 times x, I could do this straight across, it'd be x, 1x over 2. So that actually means 1/2 times x, so the slope would be, or the k would be 1/2. So 6 would be a. So we're going to look, the number of pounds in a box of sugar varies directly, it tells us already that it varies directly, with the number of ounces. Look at the graph at the right, write a direct variation equation that describes the relationship. So I have to find my k, so I'm going to look at my graph and I have to find the slope. So I'm just going to use the first 2 points, so I'm going to go from here to here. So remember, it's rise over run. But you have to look at what is this counting by. So when you rise, each one of these actually is 1/2. So that means that if I rise, even though I'm rising 2 squares, I'm really only rising 1 unit because it's counting by halves. So my rise is 1. But then let me look at my run over here. What's this counting by? Well, this is counting by 8s because 8, 16, 24, 32. So when I run this direction, it's really running 16 units because this first one is 8 and then the second one would be 8 more, which is 16. So my slope, or my k, in this is 1/16. So now that I know that, I can write my equation would be y equals 1/16x. And if you write that as a decimal, that would work, but I would just think it's easier to leave it as a fraction because just slope makes more sense as a fraction. So the next part of this says use your equation to determine the number of pounds in 80 ounces. So ounces is the x value because it's on the x-axis. So ounces, this 80 ounces, I would substitute 80 in for this x right here. So I would just rewrite it as y equals 1/16 times 80 because these two next to each other mean multiply. So I'm going to do 1/16, our constant, times the number of ounces, which was the x, that they told us to do. And when you multiply that, you would get 5, and it's going to be 5 pounds, because that's what y is actually talking about in the graph, is number of pounds. Next one, which table shows a car moving at a constant speed? My positive advice to you is to check the entire table. Don't just stop after 1 or 2, because sometimes these things try to trick you. So remember, if we're going to find whether it's constant, we're finding the k, so we have to do y/x. So this first one we would do 50 divided by 1 because we're right here. Here's my y divided by my x, so it would be 50. The next one is 150 divided by 2 because I'm doing this right here. 150 divided by 2, so it's going to be 75. So already I know that a is not constant because these two numbers are not the same. So I'm going to try the next one. So I have 50 divided by 1, we just did that as 50. 100 divided by 2 is 50. 150 divided by 3 is 50. So this one looks good, constant. I'm going to just check the last one just to be sure. So this would be 50. 500 divided by 2 is 250, so no, that one's not constant, so it would be B. Next one is going to be a slope of a line, and it gives us 2 points. So I'm going to first label my points. There's my x1, my y1, my x2, my y2. A lot of you skip this part, and then you mess up when you plug it into the formula. So make sure you label each of your points, and now we have to find our formula, which is on our formula chart, so we don't have to actually memorize it. And now I'm going to substitute, instead of y2, I'm going to substitute the actual y2 value, so it's going to be 8. Now I'm going to do minus, because that's what the formula said, y1, which is right here, 7, over, because that's what the formula says, x2, which is this value right here, so it would be 7 minus, because that's what the formula says, and then x1 is this right here, which is 5. So whenever I do this, I would get 1/2, so my slope is 1/2. I don't have to change it to a decimal or anything like that. I can leave it as a fraction. So we are going to use this table for 11 through 13. So is this relationship proportional? So in order to tell if it's proportional, I have to do the k equals y/x. So this is our x, this is our y. So I would do 2.85 divided by 1.5, and I'm going to get 1.9. Now I'm going to do 5.7 divided by 3, I get 1.9. 7.6 divided by 4, I get 1.9. If you're in my class, Miss Merle's class, then you know, a lot of times I actually write these up on top, but I ran out of room up there, so that's why I'm doing it on the bottom. 9.88 divided by 5.2, 1.9. 11.4 divided by 6, 1.9. So, is this proportional? We're going to say yes, because all of these numbers are constant. So it's constant k, so we're good. If so, we're going to write the equation. So we're going to put y equals 1.9x. Now I'm just going to stop for a second and say, if you get no right here, is this relationship proportional? No. If for some reason, like, this whole graph was different and we got different whatever, if you put no as it's not proportional, then you cannot write an equation. So then we would just write none or not applicable, or, you know, something like that right here. But if you get no here, this is going to be none. Last one, 13. Another flag in the same collection has a length of 12.6 feet. How wide would you expect the flag to be? So in this case, I just have to look back up here and remind myself that the y is the length. Okay, so this tells us the length is this. So I'm going to use this equation that I came up with, and instead of the y, I'm going to put 12.6. So let's see, I might scoot over a little bit and do it. So we have y equals 1.9x. But instead of that, I'm going to replace this y with 12.6 equals 1.9x. So I have to divide by 1.9. And I got like approximately 6.63 feet, I believe. So you could round that, whatever your specific teacher tells you to do on your test if there's decimals to round. Number 14, we're going to find the slope and y-intercept of this line. So, in order to do that, first I have to find the slope. So we're going to do rise over run. So when we do rise over run, I first look and see what is my graph counting by. Well, this graph is counting by ones on the x-axis and the y, so we're good. Then I need to see where some points are. So anywhere it crosses right at the corner, we could put a point there. So there's some points. Before I even look at the rise and the run, I can look and see, is this slope positive or negative? So because from left to right, just like I read, it's going down from left to right, so I know it's going to be negative. The other thing I do is I draw these lines in. Does that make an N? Absolutely, so my slope is going to be negative. So I can use any 2 points. I'm just going to use these two. So I would need to rise 1, 2, 3, and I need to run 1, 2, 3, 4. So my slope is negative 3 over 4. Now I have to find the y-intercept. So in order to find the y-intercept, I need to see where does this line cross the y-axis. So remember, this up and down is the y-axis, so where does the line cross? Right here. We actually already put a point there, so right here. So it crosses at the 1. So it says find the slope and y-intercept represented by each table. Well, it turns out there's only one table. So first thing we have to do is find the slope. So there's a couple ways you can do this. You can find the change in y over the change in x. I just like to go ahead and label my points. That's my x1, my x2, my y1, my y2, and use the formula. But like I said, there's other ways that you could do it. So we would do 6 minus 5 over 2 minus 0. So it would be 1 over 2. So my slope in this would be 1 over 2. My y-intercept. So remember, y-intercept is when the x is 0, the y is whatever. Whatever the y is, that's the y-intercept. So sometimes we have to do some work to do that, but in this case, it already tells us x is 0 right there. So what's the y when x is 0? It's 5. So that's it. So study hard and ask your teacher if you have some questions. See you in class.